Hey, this is Rob from Brevity, and in this video, we are going to be talking about the Java collections framework for data structures in Java. Whether you're a fresher who's just beginning to code, or you're a senior with just months to go for your placements, or you have an interview tomorrow and you're doing a last minute bootcamp, don't worry, we've got you covered. Remember the good old days when we used to code a stack or a queue from scratch in the C programming language? No, me neither. Thankfully, that is now a relic from a bygone age thanks to the collections framework in Java. This enables us to code both a stack or a queue with just one line of code. The Java collections framework provides us with an architecture to manipulate multiple objects and group them together. This enables us to perform a range of built-in operations such as searching, sorting, deletion, manipulation, etc. So now here is the hierarchy of the Java collections framework. Let's break it down. Now the root interface is the iterable interface, which is extended by the collection interface. This in turn is extended by the list, the queue, and the set interface as well. If you're looking at this diagram and wondering what exactly an interface is, don't worry. It's a very natural question to have at this point. An interface is a class that is fully abstract, and we cannot instantiate an object of an interface directly. We need to use another class which implements this interface in order to use the functionality that is defined in this abstract class. For example, in this diagram, we can see that the ArrayList class implements the list interface. Therefore, we can create an object of type ArrayList which implements the list interface. This enables us to instantiate an object and use it in our code. But we cannot directly instantiate an object of type list. This is the distinction that you need to understand at this point. If you used arrays in Java or any other programming language for that matter, you will know that it suffers from a very static behavior. Once you declare an array of a certain size, you cannot increase the size of that array. But this functionality can be implemented by the use of the dynamic array list. So let me code both an array list and an array side by side so that you'll see the differences and understand how an array list can be used to replace the arrays in our day-to-day problem solving. Now opening Visual Studio Code, you can see that this is the usual way in which we declare an array. Int array equals new int of size 10. The way we would declare an array list is as follows. Array list of type integer L1 equals new array list of type integer. Now this syntax may seem a bit weird at first, but since every class in the Java collections framework uses a similar syntax in order to instantiate an object, you'll get used to this. Note that we're using integer here instead of the primitive data type int. That is because we are supposed to put the object notation of these primitive data types inside the angular braces. So int will become integer, char will become character, double becomes double with a capital D, and string remains string because string itself is a data type of type object in Java. Now note that every time when we use the ArrayList class or any other class in the Java collections framework, we need to import java.util.star. So how do we add values for an array in Java? We'll do something like, initialize a for loop for int I equals 0, I less than 10, I plus plus, and we'll say array of I equals I. So right now the array contains values from 1 all the way till 10. The way we'll do this in an array list is kind of similar. We're going to use the L1.add, where L1 is the name of the array list itself. I declared it as L1 over here. And the .add method is going to add an element to the array list. So in this case, we're going to add elements from 3 all the way till 10. So let's print this array list and see what it has inside. Yeah, we can see that it's printing 3, 4, 5, 6, 7, 8, 9, which are the integers which I've added to the array list at this point. Now, how do you retrieve a value from an array? We'll do something like array subscript of 5, where we're going to put 5 inside these square brackets. In an array list, we are going to say .get. So this is the equivalent code to fetch a value from an array using an array list. Okay, let's say that we wanted to manipulate a value in the array. We're going to do something like array subscript 5 equals 100. And in Java, in ArrayList, the equivalent code will be the dot set method, which is going to set the value at index 5 with the value which is in the second parameter in this function, which is going to be 100. So now whatever element is at index 5 will be replaced by 100. Now this is all we can do with arrays, right? But ArrayList offers us much more functionality than the traditional array. For example, we can use the dot index of method to find the index of a particular element. In this case, when I call L1 dot index of 3, it's going to return a value of 0 because currently 3 is present at index 0 of the array list. Similarly, we can also use the last index of method in order to return the last index of a particular element. In this case, if there are multiple 2's in the array list, then it's going to return the last index of the element 2. In this case, 2 is not even present in the array list, so it's going to return a value of -1. If you want to remove an element from the array list, we can use the L1.remove method. If you want to check the size of the array list, like in terms of arrays, we use the arrays.length, the array.length. In ArrayList, we are going to use the name of the ArrayList.size. This is going to return the size of the ArrayList. We also have the L1.clear method, which is going to clear each and every element from the ArrayList, and it's going to make it a blank ArrayList. Then we also have the L1.isEmpty method, which is going to return a boolean value of true if the ArrayList is in fact empty and false if not. So let me run the last few lines of code so that we'll see what output we are getting. We got 5 when I printed the element which is in the 5th index of the array. We got 8 for the array list. For index of 3, it returned 0, which is what we expected. For last index of 2, it returned -1. This is because 2 is not present in the array list. And when I printed dot size, is returning 6, which is the current length of the array list. And dot is empty, it's returning a value of true because we have cleared the array list over here. So all of this is what we expected. Now if you're a bit more experienced with arrays, you'll know that Java has an inbuilt method in order to sort the arrays, and that is the arrays.sort method. Now of course the collections interface also has an equivalent for this function, and that is the collections.sort function. So let me show that side by side over here. This is the code which we'll use to sort the array, arrays.sort array. This is what we'll use to sort the array list, collections.sort L1. And now if I'm going to print the array list, it's going to return the sorted array list. So I'm going to comment all of this out because we don't need this anymore. Okay, so now I'm going to run this code and we're going to see what sort of output we get after sorting the array list. And over here, this is the array list before it was sorted, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, which are the elements I've added on line 50 and 51. And I've sorted the array list on line 57 and I'm printing it again on line 59. So the second time when it gets printed, it's printing the values in the ascending order, which is the sort of behavior we expected. Also, side note, we can reverse the array list as well using the collections.reverse method. This will be useful in some cases when you're trying to determine if a string is a palindrome, or if you want to reverse the array list for any sort of function or code, you can use this functionality as well. Moving on, we'll shift our focus to the stack and queue data structures in Java, how they are implemented and why they are used. Now the stack is the last in first out data structure, LIFO for short. This means that the last element which is added to the stack is going to be the first element that is removed from the stack. This is kind of similar to when in our school days, we used to purposely put our test papers at the bottom of the pile so that they'd be the last papers to be corrected by the faculty. And we wouldn't have to have our marks read out in class. Now coming back to our topic, the major methods that we will deal with in terms of a stack is going to be the .push method to add an element to the stack, the pop element to remove an element from the top of the stack, and the peek method in order to get back the element which is currently on top of the stack. Now moving on to the queue. The queue is a first in first out data structure, FIFO for short. This means that the first element added to the queue will be the first element removed from the queue. So the methods which we would use to implement such a data structure would be the enqueue method in order to add an element to the end of the queue, the deque method to remove an element from the front of the queue, and the peek method in order to return the element which is currently at the front of the queue. So how do we implement these structures in Java? enter the Deque interface. Now the Deque interface is the acronym for the double-ended queue, and it extends the queue interface. Since Deque is an interface, we cannot directly use it in our code. Thus, we'll be using the linked list class, which implements the list interface in order to use the functionality of the Deque in our codes. The Deque interface offers us three simple methods: the Deque.addFirst method, the .addLast method, and the .removeFirst method. Now I can see the gears in your brain already twisting and turning and arriving at the answer as to how we would code a stack or a queue using this Deque interface. So let's go to VS Code and do it for ourselves. Now this is the way I'll be declaring a Deque. It's kind of similar to an array list. So here since I'm using the Deque class, I'm going to be declaring Deque over here. And the type is going to be of type integer because I'm going to add integer values to the Deque. Stack is going to be the name of this current Deque which I'm going to be using. So it's just a variable and you can name it whatever you want. I'm naming it stack in this point. And we are declaring it as a new linked list of type integer. As mentioned, since Deque is an interface, we cannot directly use it. So we are going to make it implement the linked list. So now if we want to add an element to the stack, we are going to use the .addFirst method, since in a stack, elements are inserted from the top of the stack. So first I'm going to be inserting 1, then I'll insert 2 on top of 1, then I'll insert 3 on top of 2, 4 on top of 3, and 5 on top of 4. So I'm going to accomplish this by using the .addFirst method, and right now I've added 1, 2, 3, 4, 5. So let me go to Visual Algo and show how this is actually demonstrated. So this is going to provide a graphical interface where I can show you how a stack is going to be used behind the scenes. So let me push the same elements. I'm going to push 1, 2, 3, 4, and 5. So now we can see that every time when I added a new element, it kept adding at the top of the stack. So after I added 1, when I added 2, 2 was added on top of 1. Similarly, when I added 3, 3 was added on top of 2. So this is the sort of functionality we can expect from a stack, and that is what I've coded in VS Code as well. So now I'm going to be popping an element from the stack, and we'll notice that elements are popped from the top of the stack. 5 was now popped from the stack. Now let me do 4. 4 is removed and 3 becomes a new head. So this is a behavior when you remove an element from the stack. So in order to remove an element, we'll be using the stack.removeFirst element, because in the stack, elements are removed from the top of the stack. So I'm going to do stack.removeFirst twice, and then I'm going to print the stack again. I'll print it once before executing the removeFirst method and once after. Now running the code. Yeah, this error comes sometimes when I use this runner class, which is an extension for VS Code. Yeah, it worked now. So 5, 4, 3, 2, 1 was the order in which the elements were in the stack. And after I removed 2 elements in the stack, it now became 3, 2, 1. So this is us implementing the pop method in a stack. The next method which we have to implement is the .peek method. Now, in order to do this, we can just directly do the .peek method, which is provided in the Deque interface. This will return the element that is currently on top of the stack. So in this case, when I print stack.peek, it is going to return 3, which is the current head of the stack. So running it again. Yes, 3 was now printed. So currently when I print stack.peek, it's going to return 3 because 3 is the element that is currently on top of this. So now let us implement a queue using the same Deque structure. Now it's extremely similar, so I'm just going to comment out this line of code. Now over here, it's the same declaration for a queue, except I've changed the name of the variable from stack to queue. Now, in order to add an element to a queue, which is the enqueue operation, we know that in a queue, elements are added to the end of the queue. So we won't be using the addFirst method. Instead, we'll be using the addLast method. Now, this is the only difference you'll find. So since we are always adding an element in a queue to the end of this queue, we are going to use the .addLast method. So I'm adding 1, then 2 after 1, 3 after 2, 4 after 3, and 5 after 4. So now when I print the elements of the queue, it's going to print them in order from 1 to 5. So running it. Yes, we have received that as the output 1, 2, 3, 4, 5. Now let me go to Visual Algo and demonstrate this for you. So first let me add 1, then I'll add 2. You can notice that now 2 becomes a tail. Now I'll enqueue 3. Now 3 becomes a new tail. I'm enqueuing 4. 4 gets added after 3. And now 5 gets added after 4. So now if I want to dequeue an element from the queue, I'll have to remove it from the head. So now if I run dequeue, it has to remove 1 and make 2 as a new head. Then when I run dequeue again, it's going to remove 2 and make 3 as a new head. Now how would we implement this in code? When you think about it, we are always removing elements in the front of the queue. So we can use the same .removeFirst methods to remove an element from the front of the queue. Note that it's the same thing we did for a stack as well. So removing an element is the same for both stack and the queue. We always remove from the head. So now I'm running .removeFirst twice. So it's going to remove 1 and 2 from the queue. And only 3, 4 and 5 is going to be remaining. So now let me run this real quick. We can see that 1, 2, 3, 4, 5 was printed first. Then after I remove 2 elements from the queue, 3, 4 and 5 are printed. Now note that since both in a stack and a queue we are using the .removeFirst method to pop an element, we can use the equivalent queue.poll method as well. Now some interviewers and programmers will use the .poll methods, and just including it over here for you so that you'll be aware of this. And similar to a stack, we can use the .peek method as well. This will directly return the element that is currently in the front of the queue. Now talking about time complexity. Adding or removing an element from either a stack or a queue is going to be O of 1. Searching for an element in either a stack or a queue is going to be an O of n operation. And that's all there is to know about both a stack and a queue. Moving on, let's talk about the set data structure. Now the set interface also implements the collections interface. And it's an unordered collection of Java objects which will not accept duplicates. I repeat, duplicates will not be accepted in a set. This means that if you have a set of 1, 2 and 3 and you decide to add 2 again to the set, your output is still going to be 1, 2, 3. So let's discuss some of the operations which we'll now use in sets. Let's travel back in time to our school days. Do the terms set intersection or set union ring a bell? Let me demonstrate this in a whiteboard tool. Now I'm creating 3 sets S1, S2 and S3 with the elements as shown in the whiteboard over here. Now first let me create these 3 sets in code. So I'm going to create 3 sets. Now since a set is an interface, we cannot directly create objects of type set. So we're going to use the hash set class which implements the set interface. So again, similar to both the ArrayList and the Deque, we are going to be declaring hash set integer s1 equals new hash set integer. S1 is the name of the first hash set, S2 is the name of the second hash set, and S3 is the name of the third hash set. And now I'm going to add 1, 3, 4, 5 and 6 to the first hash set, which is what I'm doing here. Next I'm going to add 2, 4 and 6 to the second hash set, which is what's done over here. I'm going to add 3, 6, 7 and 8 to the third hash set, which is what is done over here. Now note that if you wanted to remove an element from the hash set, we'll just be using the .remove method, which is the same thing we dealt with when using an array list. So throughout the collections interface, these methods do remain the same, which is one of the advantages of using the Java collections framework. Now, what is the first operation? Of course, it is a set union operation. Now the union operation is going to combine the 2 sets and return the elements which are part of either S1 or S2. So in this case, it's going to return 1, 2, 3, 4, 5 and 6. So how do we do this in Java? Thankfully, there is a single line of code. There's a method which will directly return the set union operation, which is the add all method. So when I run s1.add all s2, all the elements in both s1 and s2 will now be stored in s1. So now if I print s1, it's going to print 1, 2, 3, 4, 5 and 6. So now when I ran s1.add all s2, I got the output 1, 2, 3, 4, 5 and 6, which is exactly what we expected for the set union operation. Moving on, let's talk about the second operation, which is the set intersection operation. Now the set intersection operation should return the elements which are common in both S1 and S2. In this case, I'm taking S1 and S3. I'm doing a set intersection operation, which should return 3 and 6 as shown in this diagram. So in Java, we'll be using the .retaiNall method in order to accomplish the same. So I'm doing S3.retaiNall S1, and now I'm going to print S3. So now all the elements which were common in both S3 and S1 is now going to be there in S3. So let me just execute this line of code. And we can see that the second thing that was printed was 3 and 6, which is exactly the output we were expecting for this purpose. Now the final operation that we'll be talking about is a set difference operation. This will, so when we run S1 difference S2, it's going to remove all the elements from S1 which are a part of S2 as well. So in this case, we should only return 1, 3 and 5. So the way we do this in Java is the .removeAll method. So we just run s1.removeAll s2, and it's going to remove all the elements from S1 which are a part of S2 as well. So let me just run that real quick. And it should return 4 and, no, it should return 1, 3 and 5. So running this, the same code runner error. Yes, and now we got 1, 3 and 5. And the other methods which we can use for a set is the .size method, which is going to return the size of the set. The .isEmpty method, which will return a boolean value of true if the set is empty and false if not. And the .contains method. So this can be used to return a value of true if this object is indeed present in the set. Since S1 does contain 1, it's going to return a boolean value of true. And the best part about this operation is that it is an O of 1 operation. So you'll be seeing people use the hash set a lot for getting ridiculously good time combinations. The s1.clear method will remove all the elements from the hash set, and in order to iterate through a hash set, since there's no concept of indexing, you cannot do for int I equals 0, I less than set.size I plus plus sysout I, it's not going to print the elements. So we're going to use something called a range based for loop. Now this syntax seems a bit not unfamiliar to you. It's okay, it's not really that hard. What we're doing is we're going to iterate through each element in S2, and since we know that each element is of type int, we're going to say for int I is just a variable, you can put whatever you want. So for int I, this colon represents in. So for int I in S2, print I. So it's going to iterate through all the integers in S2, and it's going to print them out for you. And that's all there is to know about the hash set. The last topic we'll be discussing is the map data structure in Java, which represents a mapping between a key and a value. Now, since the map interface is not a subtype of the collections interface, it'll behave a bit differently compared to the other types. So why should we use the map interface? If you have dealt with Python before, you would have come across something like this in the form of dictionaries. So it's very useful if you want to map a key to a value. Let's say that you have a student database and you want to map the register number of a student to the name. So when you just say set.get the name, it's going to set.get register number, it has to return the name. So there are many instances of this sort of behavior which we would like to use for our day-to-day problem solving. So it's really crucial to understand how the map interface works. So let me implement that in code. Since the map is an interface, we cannot directly implement it as always. So we are going to be using the hash map interface, which will be implementing the map interface. And we can see that it's kind of similar to the ArrayList declaration, but we are going to have two data types inside the Angular braces. The first one is the data type of the key, and the second one is the data type of the value. So over here, I want to create a mapping between the register number of a student, which will be an integer, and the name of a student, which is going to be a string. So now let us add some values to the map. So the way we'll be doing this is a .put method in a hash map, and we'll be putting two parameters inside the put method. The first one is the key and the second one is the value. So in this case, 100 is going to be of type integer, which is a key, and Amit is of type string, which is a value. So I've added three entries to the map, and now I want to check what the name is for a student with a register number of 100. In order to do this, I would just do map.get100 and it's going to return a value of Amit. Now let's say that you want to check if a particular key is present in the hash map or not. Like let's say you want to check if 101 is present in the hash map or not. Then we can use the map.contains key. This will return a value of true if the key is in fact in the map and false if not. We can also use the .size method in order to return the size of the hash map. And let now let me print the what I've gotten so far so that we'll be seeing if the output is what we expect. And running the code, we got a value of Amit for map.get100. We got a value of true for does it contain the key 101. We got a value of 3 for the size of the map. And now when I print the map itself, it's going to return 100 Amit, 101 Vijay and 102 Rahul. Now if you wanted to remove an element from the hash map, it's very simple. You would have guessed it by now. It's going to be the .remove method. So if I just say map.remove 101, where 101 is the key value, it will directly remove 101 from the map. So now the map will only contain 100 and 102. Now what if you wanted to replace? Let's say that the student with register number 100 102 left the college and a new student is replacing him and he is getting that same register number. So in that case, we can just simply run map.put again with the same register number, but you can change the value of the key. So this will override the value of Rahul and put Robin in its place. We can also use the map.isEmpty method in order to check if a map is empty or not. This will return true if the map is empty and false if not. And last thing is, how would you iterate through a hash map? Now we don't have indexes in a hash map, so we cannot just do for int I equals 0, I less than size, I plus plus print I. That won't work in the case of a map. So again, it's going to be a range-based for loop, and it might look a bit different. And this is the syntax, and let's break it down. So what we're doing is we're opening the for loop and we are saying for integer key. Why integer? Because in this particular hash map, the key is of type integer. So we're going to say for integer key. Key, you can put whatever value you want. It's just a variable. You can put key, you can put pumpkin, you can literally put whatever you want. It doesn't matter. But over here I put key. And then map.keySet, this will simply create a set with all the keys in the map. So that you can iterate through this particular set and you can print out all the keys. So this map.keySet is just a method you have to remember if you want to do this. And then we are just going to print out the key along with map.getKey. So it's going to print 100 and map.getKey will be Amit. Then it's going to print 102 and map.getKey will be Rahul. So that's the output which we can expect if we run this code. Keep in mind you have to learn this, like there will be several problems where you'll have to iterate through a hash map. So it's very crucial that you remember this line of. And yeah, that's exactly what output we got. We got 100 as Amit and 102 as Robin. Now coming to the time complexities, adding an element is going to be O of 1. Getting the value of a particular key is also going to be O of 1. Since the time complexity is so good, like O of 1 is the best possible time complexity you can get, people use this a lot in problem solving. So it's crucial that you use hash map as a vital tool in your problem solving kit. With that, we come to the end of this video. I purposely did not cover some topics, such as the priority queue, which is Java's implementation of the heap data structure, as well as some of the more complex iterations of the map and the set data structure, such as the linked hash map, the linked hash set, the tree map, and the tree set, because they cover topics such as iterators and comparators, which will overwhelm you with too much information in a single video. I will talk about these topics in detail in part 2. Stay tuned for that and more. This was Rob. You're watching Brevity. Thank you and goodbye.